cylinder of a mass of 8 kilograms is resting at the top of an inclined plane at the height of 4 meters. The inclined plane makes an angle of 20 degrees with the horizon. A solid copper ball of mass 4 kilograms is placed next to the cylinder. If both are released at the same time and only slid on the ramp,
8 kilograms. Okay.
yeah, what will each of their speed be? Potential energy and kinetic energy be at 2/3 of the way down to the incline, which will be the first to the bottom. What will be their final velocity at the bottom?
Okay.
Wait, and when you do this, can you do it like how you did like part A, part B? Can you like separate it?
Try.
Because that would really help.
So, what it asks is we have an inclined plane, we have a 4 kilogram ball and an 8 kilogram cylinder, right?
Mm-hmm.
We're assuming it's sliding, so we're only talking about potential kinetic energy. We're not talking about any rotation or anything like that. The height of this thing is h, which I don't remember what you told us that it was, but it's some height, right? And it's saying what is the, at this point, at 2/3 of the way down the ramp, right? 2/3 of the way down the ramp means that a height of h over 3, right? I want to know the potential energy. I want to know the kinetic energy, right? I want to know the speed. That's what it's asking for, right?
Mm-hmm.
And then there's another part in the end. But for this part, first part, it's asking for these three, right?
Yeah.
So in general, at the top of this guy, because we're being released from rest, all we have at the top is potential energy, right? So the potential energy equals the total energy at the top, because we don't have any kinetic, it's released from rest, so the speed is 0, okay? So that means that our potential energy here is going to be what? It's going to be mg times h, right? So the first thing we're going to do is we're going to find the potential kinetic energy here and the potential kinetic energy here, and then compare the two. And if you remember, the reason we're going to compare the two is because the total energy here has to equal the total energy here, right? And the total energy here is going to be potential energy plus kinetic energy, right?
Mm-hmm.
At this point, because it's moving and it still has some height. Okay? So let's do that. So the first thing we do is we find the potential energy here, and here the potential energy is going to be what? It's going to be mh over 3, right, times g, right? Because it's h over 3 is the height, yeah? And the kinetic energy here,
I thought the height was 4 meters.
but sorry, just keep it as h for now. Right?
Oh, okay.
And then m times v squared, right? So that's our kinetic energy here.
Mm-hmm.
And we're saying that the two have to be equal. So step 1, right, we find at the top potential energy, right, kinetic energy, and the total energy at the top, which is what we did, right? And then step 2, we find, this is at the top, at h, right? And then we find the potential energy, kinetic energy, and the total energy at h over 3.
Mm-hmm.
That's the second step. The third step is we compare it, right? The total energy at the top has got to equal the total energy at h over 3. Because energy is conserved,
Mm-hmm.
right? So that means that I have to make this equal to that. So that means, right, that mgh equals mgh over 3 plus 1/2 mv squared, right? That's potential plus kinetic, and the potential, right? So in this problem now, step 4, right, we solve for what? We're solving, what do we know? We know m, g, and h.
Mm-hmm.
The only thing we don't know is v.
Mm-hmm.
That's what we don't know, right? So we're solving this for v, right? So we say solve for v. Right? So in solving for v, we're going to bring this over. So we have an apple minus 1/3 of an apple leaves me 2/3 of an apple, right? So it's going to be 2/3 mgh, right? Equals 1/2 mv squared. You see what I did there? I brought over, this is h over 3, right?
Yeah.
So I have an apple minus 1/3 of an apple leaves me 2/3 of an apple.
Mm-hmm.
Okay?
Yeah.
And we notice m's go away, right? M's go away. And I can multiply both sides by 2, because this is 1/2, right? So this becomes 4 over 3 g times h equals v squared. That's what that says, right? If I multiply both sides by 2, right? Right? This cancels, I'm left with 4 over 3 GH equals V squared, right? So we solve for V. So that means that V equals the square root of 4 over 3 G times H, right? And what we find, there's no mass in here, right?
Mhm.
So that means they both are going to have the same speed at this point, right? So now that means we have the square root of 4 over 3 times, let's just use 10 to make life easy, right? For acceleration of gravity,
Okay.
right? Times the height was 4, right?
Yes.
And that's the square root. So 16, so whatever this number is, whatever the 6.7 blah, blah, blah meters per second, or whatever that number ended up being. I don't remember.
Uh, 7.30.
7.3, okay. You sure?
Yeah, I did 4/3 times 10 times 4.
Oh, 4/3 and 10, okay.
Yeah.
But you
and I
did square
put,
root.
yeah. We
Okay,
can
no,
look
it's
at the
fine, I
calculator.
believe you, I just remember anyways, okay, so meters per second. Okay, so there you go. So now step 5, now you're gonna find PE and KE, right? So PE at this point is, you know, 1/3 mgh, right? Which is 1/3 times 4, oh, you're gonna do it for each, so step 5, you're gonna find the potential kinetic energy for each mass, right? So this is gonna be for the ball, right? Yeah? So this is
Okay.
gonna be 1/3 times 4 times 10, right? Times 4 the height, right?
Okay.
And that's of course 160, so it's 160 divided by 3, right? Joules. And then the kinetic energy for the ball, right? That's going to be 1/2 mv squared, right? And the mass of the ball, of course, is 4, right? So that's going to be 1/2, and then the mass is 4 times v squared. But we have v squared right here, right? We have, v squared right here. So we multiply this times 4 over 3 times 10 times 4. I mean, it just saves me having to write some numbers. So this is going to be 4 cubed, 16, 64, 640 divided by 6, right? Whatever, you guys did math, okay? So that's for the ball, right? The ball. And then for the cylinder, potential energy for the cylinder is going to be 1/3 mgh, right? Well, the cylinder is the same, it's just the mass is twice as much,
Right.
right? So you just say twice 2 times this guy, right? Whatever this is. Right? And the kinetic energy is the same, it's just going to be cylinder, it's going to be, of course, 1/2 mv squared, right? And it's just going to be twice as much, right? So it's going to be 2 times whatever this number is, right? 640 over 6, right? So that part gets you your answer here. You're done, right? You found the speed, kinetic energy, and the potential energy. So you're done that part, right? Next, you're asked to find what the final speed is here, right? Let's be final, yeah?
Yeah.
And you're also asked to find who comes there first.
Well, they both get there at the same
Well,
time.
but you have to figure it out. Okay, so for six now, you have to, can you see that? Or it'd be better over here? Here, 6.
I'll just hold
Okay,
it.
so part 6 we
It'll
have,
be shaky if you do that, though.
we have the potential
Yeah.
energy, right? Here is going to equal the kinetic energy. It's all kinetic here, right? There's no potential, right? Equals the kinetic energy at the bottom. The total energy at the top equals the total energy at the bottom, right? So in this case, we have mgh equals 1/2 mv squared. That's it. And again, we notice the masses go away, so it doesn't matter what the mass is. So this one says what? It says that v squared equals 2gh,
Okay.
right? And that means that v equals square root of 2gh. Which I thought was like 7.6 something, right? Anyway, so that's the speed, and because the speed is independent of the mass, you make the point. Speed's independent of the mass, therefore the masses will arrive at the same time.
Mm-hmm.
Yeah?
Yeah.
Okay. And this, I think, is something like 7.6 meters per second. Something like that. And that's it. That's the whole problem. Does that make sense?
I think so. I think I think it'll be easier for me to do it this time just because I have the steps and we did the video